Question 1A says aluminum chloride is a white solid. Okay, it's a white solid at room temperature, which readily sublimes at about 190 degrees Celsius. Hello, Tug. And some data related to aluminum chloride is shown below here. So we have enthalpy change of formation, we have enthalpy change of atomization of the metal, we have bond energy of chlorine, we have bond energy of aluminum and chlorine. Okay, so we use the above information, we need to draw an energy cycle and calculate delta H1, which is given as the sublimation of aluminum chloride solid. Okay, so we're gonna start off with this sublimation equation, which is, I wrote it as our aim equation. Okay, so let's just put it in, and then maybe we can make use of the first enthalpy. And guys, as we are using the enthalpy change of formation, right, and whatever that you're going to use, just cancel out the things that you have used. Okay, so for example, maybe the first one we're going to use enthalpy change of formation, aluminum chloride, AlCl3. You guys can actually see this properly. Let me know if you cannot see the diagram. Okay, so maybe to form AlCl3, we need what? 1 aluminum, and we need 3 atoms of Cl. Okay, but we know Cl doesn't exist as atoms, Cl exists as molecules. Okay, so Cl exists as like Cl2. So since we need 3 atoms, let's just put a fraction 3/2 in front, so that when we multiply out, we'll get 3 atoms of Cl. Okay, so let's do this. I'm gonna shift this a little bit. Okay, hopefully you can still see. I'm gonna put Al solid. Remember, aluminium is solid, right? If you didn't know that, God bless you. Okay, aluminium solid plus 3/2 chlorine gas. Okay, so this is the first enthalpy, and we're gonna put this enthalpy in delta H formation of AlCl3. Okay, so this number will be -704. Okay, once you have used it, right, basically just cancel out the enthalpy, and then that's it. Okay, so we have used up one of the enthalpy change, and basically let's look at the next one. Which one can we use? We can use atomization of aluminum. Okay, atomization of aluminum, let's go ahead and use that. Atomization, delta H atomization of aluminum. This value will be +326. Okay, so we cancel it out as soon as we've used it, and that's it for atomization of aluminum. The next thing that we can do is, okay, then the next thing we're going to use, right, back to the question, we are going to use the bond energy, so times 3/2. Okay, so 3/2 bond energy of chlorine. Okay, and then now since we used it, we're going to cancel out the 244. Okay, this number will be 3/2 times 244. Okay, so we have used 3 of the enthalpies, and since we have atomized both aluminum and chlorine, basically just put down the atoms. Oh, sorry, wrong color. Aluminum gaseous plus 3 chlorine gaseous. Okay, so we're done with atomizing both metal and non-metal, and what are we left with? We're left with the bond energy of aluminum and chlorine. Okay, so aluminum and chlorine bond energy, there's 3 of them in aluminum chloride. So we're just gonna go all the way from here, all the way like this. Okay, so AlCl3 looks something like this if you didn't know. AlCl3. Okay, so there's 3 of such bonds, and we're just going to put bond energy times 3. There's 3 of it, 3 of the bond energy of aluminium chlorine. Okay, and there you have it. You have the whole energy cycle. We used up all of the information the question has given to us. And now we can use Hess's law to actually complete the calculation. Okay, so this is the second part where they ask you to calculate delta H1, which is this number over here. Okay, so go ahead, use your highlighter and basically do the clockwise equals to anti-clockwise. So maybe you can do something like this. For me, right, I try to go along with the direction. Thank you, Sniper. You're so nice. Thank you so much for sharing the light. Thank you. So we start off with the elements here, right? We're starting off with the elements here. Box it up for you. Okay, so we are doing a clockwise, right, with green arrows, and then let's do anti-clockwise with actually I think we can extend the green arrow a little bit. Let's extend this green arrow all the way like this. Okay, and then we have the yellow arrows just going down like this. Yep, and then you can actually just write down the arrows that are on the yellow arrow. Okay, let's do this. Maybe we write our own Hess's law equation. So yellow arrow, positive 326 plus 3 over 2 times 244. This will be equals to minus 704 plus delta HF. This is the one that we're trying to find. Delta H1, sorry, not delta HF. Delta H1. H1. Okay, and then plus the 3BE of ALCL. Okay, so ALCL, what's the number again? ALCL 3 of it is 502. Okay, so you can put in 502 directly. That's also fine. Okay, otherwise, the answer is negative 110. Well done. Well done. Okay, let's look on at part 2. State why the answer obtained in A part 1 is an unreasonable value. Why is it unreasonable? They say state means that it should be very obvious. Okay, because sublimation by right is supposed to be endothermic, but our answer was exothermic. So it doesn't make sense. It should be an endothermic reaction because it takes energy to convert from a solid to a gas. Okay, it takes energy to convert from a solid to a gas. Okay, then after that, the second part of the question actually says suggest 2 reasons why the value is nonetheless obtained. Okay, why we obtain this value. Okay, so common reasons. It is estimate average value. It's an approximate value from the data booklet. And what's so special about ALCL3, right, is that it is a covalent compound with ionic character, with a lot of ionic character. So this is one of the things that is special about ALCL3.